Alright, let's move on to example 3 in our 4.3 notes. Okay, example 3 asks us to find the remaining zeros of each function. Okay, and we're given the polynomial function x to the fourth minus 7x cubed plus 14x squared minus 38x minus 60. And I'm given that one of my zeros is 1 plus 3i. Now, this is an imaginary complex zero, so we know that we must also have its conjugate. So if I have 1 plus 3i, I know that I also must have 1 minus 3i. So really I have 2 of my zeros. Remember, if we were given zeros before and they were real zeros, we would divide by the piece that that real zero gives us in our polynomial function to find the remaining pieces of our polynomial function. Okay. This is the same concept. So we're given these zeros. We need to figure out how they fit into our polynomial function and divide by that part in order to get the rest, the remaining part. Okay. So our first step is to figure out how this fits in my polynomial function. So we can either use the method where we took x minus our 0 and had the positive conjugate and the negative conjugate here, or that other method that we used where we set x equal to our two conjugates, our positive and negative, and then solve so that it equaled 0 and multiply it out. I prefer this method only because it takes less room on the paper. You may use either method. Just know that if you're following along here, I'm going to be using this method. So if we're using this method, we would set x equal to 1 plus or minus 3i, because that is my two conjugates. Alright, and now we know we need to solve so that this side equals 0. So first I know, easy, I can subtract my 1 to the other side. So this becomes x minus 1. And then I remember from earlier, I want to get rid of any imaginary pieces because I don't want imaginary pieces in my final polynomial function, because it's not a polynomial function if coefficients and the numbers are not real, correct? So we need to get rid of those imaginary pieces. So I know in order to get rid of I need to get rid of the imaginary part, which is the square root of negative 1. In order to get rid of that square root, I need to square both sides. So x minus 1 squared on the left, and I have to be very careful when I multiply this out because this is this entire piece squared, not just my imaginary piece squared. So when I square my positive or negative, remember squaring a positive gives us a positive, squaring a negative gives us a positive as well, so this is going to become positive, both of these parts, so we don't need to worry about that anymore. 3 squared gives me 9. Then remember, I is negative 1, so when I square negative 1, my square root and my square cancel, and I'm left with negative 1. So 9 times negative 1 is just negative 9. But I'm not done yet. Remember, this is a 0, so this side should equal 0 on my polynomial function. So I need to remove this negative 9 to make this side equal 0, so I need to add that to the other side. So I have x minus 1 squared plus 9 equals 0. Finally, I have this in the form that I can plug it into my polynomial function as a factor. However, it's not really something I can divide by yet because it's not in the form of a polynomial. So I need to FOIL out this x minus 1 and this x minus 1 and then combine my like terms. So when I FOIL out my x minus 1, I see that I have x squared minus x is negative 2x plus 1, and then plus my 9. Combine like terms, and I get x squared minus 2x plus 10 equals 0, and I have something I can divide by, something that I can plug straight into my polynomial function. So now I move on to the dividing portion of the problem. Okay, so remember, in order to find the rest of my zeros, when I have a 0, I can divide it from a polynomial function, get what's left, find the zeros of that piece that's left. Doing the same thing here. So we take our polynomial function x to the fourth minus 7x cubed plus 14x squared minus 38x minus 60. And we divide it by the polynomial function we have over here. So x squared minus 2x plus 10. Let me zoom in a little bit here. We're just dividing this out. Now this time we can't be using synthetic division, right? Because we don't have something in the form x minus c. So we have to be using log division this time. So it's important that you know how to use log division. So this polynomial, our dividend, and this polynomial, our divisor, and we're going to divide them just like normal. So we know in order to get x to the fourth from x squared, we need to multiply x squared. And then we multiply this term out, so x squared times x squared, x to the fourth minus 2x cubed plus 10x squared. Subtract first. Don't forget to subtract to all terms, and then combine like terms. So x to the fourth minus x to the fourth is 0. Negative 7x cubed plus 2x cubed leaves me with negative 5x cubed. 14x squared minus 10x squared leave me with plus 4x squared. And then I just bring down the rest, 38x minus 60. And then I repeat. So x squared times negative 5x gives me negative 5x cubed, and I multiply negative 5x cubed plus 10x squared minus 50x. Subtract and distribute my negative. So 0x cubed minus 6x squared plus 12x minus 60. And I continue again. X squared times negative 6 gives me negative 6x squared. So this becomes negative 6x squared plus 12x minus 60. And I subtract all of my terms, and I see that this is 0, and this is 0. Remainder of 0, which is what I expect if I have a 0, correct? It should go in evenly, so I should have no remainder when I divide it. So if I'm not getting that 0 as my remainder, I'm probably doing some of my division wrong, or I found my polynomial part incorrectly. Okay, so now that we finished dividing, we know now that x squared minus 2x plus 10, that polynomial piece we got earlier, times that quotient that we got, x squared minus 5x minus 6, should equal that original polynomial function that we have. Can I do anything with this? Can I glance at this and kind of see something that I might do? It's factorable, right? So I know that negative 6 times positive 1 gives me negative 6, and negative 6 plus 1 gives me negative 5. So I can factor this into x minus 6 times x plus 1. And now I've completely factored my polynomial function, right? I've factored until I cannot factor anymore. So I already know that this provides me with the zeros 1 plus 3i and 1 minus 3i, right? Now I can also see that after I've divided, I also have the zeros positive 6 and negative 1 from these two pieces. So all of these things we learned in the past coming back to haunt us in these problems. So we need to be able to do our long division we need to be able to do our factoring in order to solve these problems. But that is it for example 3. Longer problem, but solvable using most things that we have learned in the past. Thank you for watching. Have a good evening, day, or whenever it is you're watching.